next speaker is Dr. Scott Massey's chemistry student, Mr. Jacob Gardner. He will be presenting on history, chemistry, and uses of the battery.
All right, good afternoon. My name is Jacob Gardner, and my topic today is about the history, chemistry, and uses of the chemical battery. I would like to thank Professor Massey and Professor White for helping me research and learn about this topic. Now, what is a battery exactly? Well, it's more than just this box that somehow contains the energy to power your iPhone. Really, well, first off, energy isn't something tangible. It's really just a measure of an object's ability to do work. It can be stored in many different ways: mechanically, thermally, biologically, electrically, or chemically. And a battery stores energy chemically. A battery is really just a clever way to convert a complex chemical reaction into the electrical energy that we need to power our portable devices. So today we will go over the history and development of the chemical battery, what exactly a battery is, and the chemistry behind it. The chemistry behind the three most common types of batteries: lead acid, or better known as car batteries, lithium ion, or the batteries that are in your cell phone or laptops, and alkaline batteries, which are used to power many small devices such as like children's toys or MP3 players or small radios. And then we'll go over the future of batteries in relation to sustainable energy. Now, we all use batteries every day. They're an integral part of our lives. Hopefully after this presentation, you might all learn something about the magic behind this technology and how we might apply it to the future. So, history and development of the chemical battery. The term battery first originated by Benjamin Franklin in 1749. It was originally used to describe a set of artillery pieces in series, but he used it to describe a set of electrochemical cells in series, and that's how we have the word battery. In 1800, Alessandro Volta created the world's first voltaic pile, which was an early wet cell battery. It used zinc, copper, and salt water. I actually have a video later of me recreating the voltaic pile, which we'll see in a little bit. In 1859, the first rechargeable was invented by Gaston Plante. This battery is still in use today as lead acid batteries or car batteries. And then in 1886, the first dry cell was invented by Georges Leclanche. This cell used a paste to mobilize the electrolyte, meaning it could be more portable, you could use it in different rotations, and it was in general more durable than a wet cell battery. So really quick, this is my little video kind of going over me recreating a chemical battery. I used pennies for a source of copper, galvanized steel as a source of zinc, and then paper towel soaked in salt water for my electrolyte. And then as you can see, this battery was able to generate a voltage of 3.5 volts, which when compared to a standard AA alkaline battery, that'll only do about 1.5 volts. Something to note too is that this battery didn't last very long. After about a few minutes of me using it, it was basically dead. Now, how does this work? Well, first off, batteries, or a redox reaction, for those who aren't really sure, is a reaction where the oxidation states of atoms will change, which means that there's a transfer of electrons from one atom to the other. Now, this transfer of electrons in redox reaction is what we harness for a battery. The transfer of electrons will go through a circuit and power our devices. There are three basic parts to the battery. There are the anode, which is the site of oxidation, or where electrons are given up. The cathode, which is the site of reduction, where the electrons are later absorbed. And then the electrolyte, which is the source of ions, and then that react with the electrodes to keep the reaction going. What happens is that the anode will react with the electrolyte and release electrons through the circuit. Then at the cathode, what will happen is the cathode will take those electrons and then react with the electrolyte to later create a new compound. And the transfer of those electrons is what, like I said, powers our device. The reaction will end when all the reactions are used up. And then for recharging the batteries, what happens is you apply a voltage to the battery and it'll basically reverse the reaction, resetting the system. Now, the three most common types of batteries are lead-acid batteries, like I said, used in cars, lithium ion batteries, and alkaline batteries. And we'll go over the chemistry of those three. Now, lead-acid batteries, they're used in cars mostly to the fact that they're low cost and they're long life. They consist of a lead anode, a lead dioxide cathode, and a sulfuric acid electrolyte. And again, you can see here you can see the different half reactions, which basically at the anode, that's the oxidation half reaction, and the cathode is the reduction half reaction, and then put them together, you have your net redox reaction right there. Next, we have our lithium ion batteries, which are used to power your phones, your laptops, or any high power devices that you may have. They are very popular for those uses due to the fact that they're high energy density. They use lithium ions, which are the third lightest element on the periodic table. They're low weight and they're high energy output. They consist of a graphite anode, a lithium cobalt oxide cathode, and a lithium electrolyte. Something cool about these types of batteries too is that with the graphite anode, what happens is that it's like a graphite lattice that kind of grabs onto the electron or the lithium ions, and as the reaction occurs, it'll let go, and later the lithium cobalt oxide cathode will grab onto those. And it's just cool how it kind of grabs onto things. And again, you can see the different half reactions here with the lithium cobalt, the carbon holding onto the lithium, giving it up, and then later the cobalt oxide grabbing the lithium ions and creating the new compound. Next is the alkaline battery. These batteries are used in small devices, toys, flashlights, radios, small MP3 players. There's probably a good chance you have these batteries at home in storage to be used for whatever you need to use them for. They're very popular due to the fact that they can last a while in storage. You can store them for up to 7 years in storage, just to not using them will be fine. They're also popular due to the fact that they're cheap and they're also relatively safe compared to other types of batteries. Now, the alkaline battery consists of a zinc anode, a manganese dioxide cathode, and a potassium hydroxide electrolyte. Again, the different half reactions occurring at each site, and then the net redox reaction below. And these are all covered in my paper more in depth if you'd like to go look at that. So now, how can we take this technology that we've used for the past 2 centuries and apply it to the future? Well, the big issue now is for our power grid infrastructure is that it's mostly built around non-renewable resources, fossil fuels. And how this works is that they will ramp up their output to meet the peaks of peak need, and they'll lower their output to if there's a valley or so. And basically it's used as needed. But the problem is that renewable power sources such as solar or wind, they can't do that. They can't ramp up their power when there's no sunshine or there's no wind blowing. So to kind of get around that, an idea is to build battery infrastructure around these sites to kind of shift energy storage more towards renewable power sources versus non-renewable power sources. Having the batteries available to store energy over time to kind of eventually meet the need if, again, the sun isn't shining or the wind isn't blowing. Another application of batteries to kind of promote sustainable energy would be to have batteries in your neighborhoods or in your homes to help promote solar panels or solar power on your houses. This way it can store energy to help power your home if for some reason the power grid goes down, or to also kind of mitigate the stress you put on the power grid. And then again, shifting more of our energy generation away from non-renewables and more toward renewables. Batteries have had a long history and a profound impact on the technology of today. In summary, batteries are basically just harnessing the electron movement of the redox reaction. They contain 3 basic components: the anode, the cathode, and the electrolyte. They could be used to help build an infrastructure around renewable energy rather than non-renewable energy. And they can promote the use of solar panels in communities. I do believe that batteries are a key component to help move our power supply more towards renewable energy. I also know that this technology has already had a profound impact on our modern lives and has a great place in the future. Thank you. Any questions? Yes.
Have you done any research anything about why lithium batteries sometimes catch on fire?
Yes, I have. I kind of go over that and kind of the disadvantages of lithium ion batteries. Off the top of my head, I can't remember the exact reason why. A lot of it I think has to do with, again, I can't remember off the top of my head. It is in my papers, if you want to go ahead and look at that, it'll give you kind of go over that. It's also a fun fact that they're not, you can't ship lithium ion batteries through the airport or like ship them on an airplane due to the fact that they can catch on fire. That's mostly just a safety concern. Anything else?
Are there any like cons to solar energy or anything that you came across that you looked at any of that?
Not really cons per se, but more of disadvantages. Right now, a lot of our solar energy, the production or the efficiency of our solar panels aren't as high as we'd like to be, so it takes a lot of energy and a lot of time to produce enough electricity to be used. But due to the disadvantages, it's free energy that we have available, no matter what we use it. Anything else? All right, thank you.